Everyone. Today we are starting with chapter 4, Entity Relationship ER Modeling. This chapter attempts to present fairly balanced view of entity relationship modeling. On the one hand, a pragmatic focus on the aspect of the ERD, that is entity relationship diagram, that directly impact the design and implementation of database must be considered. On the other hand, properly documenting business needs that the database must support is equally important. Therefore, we are going to learn about both Crowfoot. I mean, you have already used. We are going to use those Crowfoot diagram and Chen notation diagram of the ERDs, and we'll discuss the differences between them. The Crowfoot ERD diagram tends to be more pragmatic, while the Chen notation of ERD has greater semantic content. These are some of the learning objectives that we are going to cover today. So first we are going to identify the main characteristics of the ER diagram. Then what are the various relationships, then the components that affect the database design and implementation, and we will understand through a real world database design. We will try to build it from scratch, and we will develop it phase in different phases. First, let's start with ERM, that is Entity Relationship Model. Um, this forms the basis of the ERD diagram. This is nothing but the conceptual database in perspective of an end user. And the main components are entities, attributes, and relationships. Let's start with entities. So, an entity refers to an individual entity, not a set of entity. In ERM, entity relationship model, the entity is represented by a table and not a row. So, in Chen, Crowfoot, and there is another one notation also we will see, UML, Unified Modeling Language Notation. So here the entity is represented by a rectangle, not just the entity name. Next, we are going to see some of the attributes. So we will individually explore all these attributes listed here. So entities are represented by means of their properties, which are nothing but the attributes. This is the definition of attribute. And attributes are characteristics of an entity. An entity can have many attributes. So let's start with the attribute of a student entity. And here the Chen model and Crowfoot model are both given to you. So as you see in the Crowfoot model, the student email and student phone are optional attributes. Okay. So what are these optional attributes here? So all these bold names, these are not optional, but not bold names that the email and phone are optional. So optional attributes is something which does not require a value and can be left empty. That means you can say those attribute values are not important to the entity. And there is another one concept called domain. So domain means a set of possible values for a given attribute. Okay, so let's come to attribute 3. Uh, so in this slide, as you see in the Chain and Crowfoot model, we are going to see a new type of attribute. So here the car color, as you see, this one related to the car main entity. So it has been signified with two lines. So this is a multi-valued attribute, and it is shown by a double line. So a multi-valued attribute is something that have many values in it. See here, the car win. It's a primary key of this car entity in the chain model. Here in Crowfoot model, it is also underlined and defined as the primary key. So here as the multi-valued attribute, as the name implies, it can have many values. So let's take one example. As here the car color can be different at a certain point of time for the entity. Like that, I'm going to give you an example. A person's education may include, let's say a person education is an entity, okay, and let's say that education of a person may include high school diploma, a 2-year college associate degree, a 4-year college degree, a master degree, a doctoral degree, and various professional certifications such as certified public accounting certificate or certified data processing certificate or a computer aided drafting certificate. So a particular person's education, that entity can have such type of attributes. So an education can have multiple values at a certain point of time, and that is your multi-value. Let's see here. Tables are never created with the derived attribute values in it. So instead, the values can be calculated at the time of retrieval and shown to the user. So here we are going to see mostly the derived attribute. So derived attribute is something whose value is calculated from other attribute. So you can take one example of an employee age which can be determined using the date of birth of the employee. So let's take another example. If a person's job joining date is entered to database, but the person's experience, that is the derived attribute, person's experience, it is calculated based on the joining date of which, so the person's experience can vary on which current date you want to calculate his experience. So database view creation method is used for calculating person's experience based on his job joining date. And what are these view creation method of database? We will look into them later on. This is called your derived attributes. So there can be different types of attributes. Here using the last picture of the car entity in the chain and Crowfoot model, if you see the car color is now, that was the multi-valued attribute. Let me pull it up. Yeah, the car color was the multi-valued attribute. What are we trying to do here? We are now dividing that car color multi-valued attribute, dividing it and representing it by three new attributes: the top color, trim color, and body color. This is your multi-valued, and let's see that derived attribute. So here the person's employee age is the derived attribute, and it is drawn by this dotted the dashed line. So derived attribute is something whose value is calculated or decided from other attribute. Let's say the employee age is calculated from the employee DOB. So DOB is here. Using this DOB, we are going to create this employee age attribute. There are certain disadvantages and advantages of the derived attributes. Just look into this table to understand it. So advantage is, it saves CPU processing cycles. Okay, so if you save the employee experience at a certain place in your database, then you don't have to look into its individual date of birth of the employees for calculating the experience. And the disadvantage is it requires constant maintenance to ensure the right value is current. Let's move on to the relationships, connectivity, and cardinality in the databases. So, if you see, there are three terms: association, connectivity, cardinality. So, in the chain notation, that commonly uses specific minimum and maximum cardinalities. Specific minimum and maximum cardinalities are almost never used in practice of Crow's foot notations, which is why in practice most people who use Crow foot notation refer to connectivity as maximum cardinality and participation as minimum cardinality. So these are the cardinality. It will be better understandable through an example. So we will do that later. The association actually it shows us how the entities are participating in the relationship. So there, if let's say there are multiple entities, so in all the directions, how they are being associated in the relationship. That's your association. And connectivity can be of many type. One is to one, one is to many, many is to many, like those. Existence dependence. So here we have two terms, weak entity and strong entity. So weak entity is always dependent on a strong entity for its existence. Okay, we will look into that through an example. See, first let's see the weak relationship. From there, you will have an idea of the weak entity, and in the strong relationship, you will have an idea about the strong entity. So there are two entities, course, class. So course has CRS code, primary key class has primary key class code. So the primary key of the related entity doesn't contain a primary key component of the primary parent entity. So what's that? Here see in the course and class there is a one is to many relationship in between both of them, course and class. So class primary key, that is the class code, doesn't inherit a primary key component of the course entity. Okay, and hence a weak relation exists between the course and the class because the CRS code primary key of the course entity, that is the parent entity, is only a foreign key in the class entity. So they are related to each other, but they are not strongly related to each other. Let's say if there will be a case where CRS code, the primary key of the course entity, will also be used as a part of the primary key of the class entity, then in that case we can say that there is a strong relationship, and class is a weak entity which is dependent on the primary key CRS code of the closed entity. Hope you got an idea. What is weak entity? What is weak relationship? Now let's see the strong identifying relationship. So here the primary key of the related entity contains a primary key component of the parent entity. That's what I just told you about here in this example. So let's see. So here the course entity has primary key CRS code and class has this CRS code and class section as a combination as a primary key. So without this CRS code, class may not have a meaningful primary key, and it's always dependent on the course entity primary key. So that's why there is a strong relationship in between these two. And if I will ask you which one is the strong entity, which one is the weak entity, so here weak entity will be something which is dependent on the other entity's primary key for its own existence. That is your class. Class is a weak entity and course is a strong entity. Let's see. Um, let's try to understand the weak entities through this diagram. So see there are two entities, employee and dependent. So here see the dependent entity may appear many times in the has relationship in the Shen model, and not only once also. An employee entity must appear at least once in the has relation. Here the dependent entity needs the primary key of the employee entity to identify its own all the own records, and primary key of dependent entity is a combination of employee num and department num. So this is the in the Crowfoot model, the dependent weak entity will be designed like this in this way, and here in Chen model it will be designed like this. Okay, and the same relation, the last example has been explained here in both the tables. So how the dependent entity is using the employee num and the department num here, and how the values are corresponding. I mean, the employee values are corresponding in the employee table. So if you see, the dependent has duplicated employee num values. So as it has duplicated values, or the department num is also having duplicate values, it's almost impossible for the dependent entity to decide its own primary key. That's why it needs both employee num and department num, as the employee num attribute value in employee entity, that's unique and it's a primary key. So with the help of the employee entity EMP num, the dependent entity is able to identify all of its records individually and successfully. Let's next come to relationship participation. So if you see, there are two entities, course and class. So it shows optional participation. That means what? One entity occurrence doesn't require the corresponding entity occurrence in a particular relationship. So what does it mean? Let's take an example. Your first year experience class. It may not belong to a particular type of course. Okay, you take that class, you take that course, but it is not included in your program. It doesn't count towards your degree requirements. Now, like optional participation, you have mandatory participation. See, where you see this round, that means optional, and there is no round, there is a line, that means it has some sort of participation, either strong or weak. So in the mandatory participation, one entity occurrence requires corresponding entity occurrence in a particular relationship. So your intro to programming course, it can have many classes, and it is a required thing. Like your first year experience was not required, but you take it. But intro to programming course is mandatory, and it's needed for the completion of your degree. Then we have relationship degree. So there are different types of relationships: unary, binary, ternary, recursive. So there is a recursive relationship. So one example can be a course may be a prerequisite to another course. Let's explore all those relationships here in this diagram. So the unary relationship here, the association is maintained within a single entity. That is, employee manages also multiple employees. If in a company there are multiple employees which are being managed by a single manager, which is again one employee of the same company. Binary relationship here, two entities are associated with each other with a type of relationship. Professor teaches many classes. Ternary relationship, at a minimum, here we should have more than one or two entities. That means three entities must be there in the relationship, and they should be associated with each other in this way. And here's the same ternary relationship is also can be seen in this way. The prescribed relationship can be converted as a ternary entity, and it can become an entity in this way, and there should be a one is to many from all the entities to the prescription entity. And the recursive relationship, and it always exists within a single entity type. Okay, see, always a unary relationship is that can be also called as recursive, same thing, and it is one in which a relationship exists between occurrences of the same entity set. In this relationship, the primary and foreign keys are the same, but they represent two entities with different roles. Let's say there are different conditions such as commons in manufacturing industries and all persons have accounts in a bank. They come under this unary relationship. Let's take one simple example. Let's say one employee is married to another employee. Okay, in the same entity, you can show this unary relationship, or one employee manages multiple employees. That is also, both of these cases are recursive relationship. Mm, associative. Okay. Let's come to associative entities. So here see, initially in the many-to-many relationship between student and class entities, okay, uh, student and class have a many-to-many relationship. But here the figure has been modified by establishing a new entity enroll which has the primary key of student entity, primary key of class entity, to behave as its own primary key. And here enroll is having the primary key as a composite key, that is combination of class code student num. Okay, and these are the primary key of student and class. So this is a composite entity. Now let's move on to developing an ER diagram. These are some of the steps to create and build the ERD diagram. So let's start with the picture here. So here if you see, the professor may or may not be is a dean or not a dean of a school. The professor is a dean of 0 or 1 school. The professor can be a simple professor, he may not be a dean, or a professor can be a professor and will also be the dean of the school. And the school can operate on multiple departments, and just look at the primary keys and the characterization of all the attributes in each of the entities. So where you see a round sign like this, there is a possibility of optional participation. Okay. Now this is the full picture of tiny college ERD segment. You will find it in the book. This is a segment of that. So here, if you see, one department offers 0 or multiple course. Okay. Now the same tiny college segment, another segment we are developing. So here, one course may generate, okay, 0 class or more than 1 classes. Okay, that's the meaning of this. And semester can include 0 class or multiple class. This is another segment. At last, finally, we are going to join them together. Now let's come here in the fourth tiny college ERD segment. Here one department can employ multiple professors, not 0, multiple professors. There is a mandatory participation. And one professor may chair one department or may not chair a department. So one professor chairs 0 or at least one department. Okay. Now another segment of this. So professor may teach 0 class or may teach multiple classes. Now the next 6 tiny college ERD segment. Here we are going to find the relationship between student, enroll and class. So here each student may enroll up to, see this cardinality here. So each student may enroll in up to 0 classes, and each class may have up to 35 students. There can be 35 enrollment, thus creating many to many relationship between student and class. And let's say the student is connected to the class with a many to many relationship. It can be divided by incorporating or adding a new third entity enroll in between those two. And the relationship will be divided like this: one is to many and one is to many. The next segment, the seventh tiny college ERD segment, in between the department and student. Here, um, one student, there may be a department, or there may be one department, or may not be one department, or a zero department that has a student or may not have a student. Okay. So in the both the cases, both of them are participating in a optional participation or optional relationship. Next segment, professor advises many students or may not advise any student. Okay. Let's take the example of adjunct faculty or adjunct professor who are not involved in advising the students, but there are some professors, full-time faculties who are involved in advising the students. In the ninth segment, in between the building room and class. Now, after having everything together, now you have a total picture. You know what are the entities, you know what are the relationship names, what are the cardinalities or connectivities, okay, and how they are connected to other entities. So let's build a table using all those details from all the segments of the ERT. Now just join them all together, and this is your final completed tiny college ERT. Now this one is the UML diagram that I was telling you about. So here the same structure that you have earlier, that is being converted into the UML diagram. It looks a little bit different. Here you don't have to mention the primary key and all those keys, just the entity name and all the attribute names. But there you must mention the cardinalities. So professor to student. So there should be at least one professor. That's why it's showing one dot 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 one. So one professor advises, and the student is advised by the professor. Okay, again it is more refined. Okay, so this is how you create or build a ERD diagram. There are so many conflicting goals or design challenges involved while building a database, and here those guidelines you must adhere to. The database design must conform to all design standards. Whatever concepts you have learned, it should be appropriately placed in the ERD. And the high processing speed may limit the number and complexity of logically explained relationship, and the maximum information generation may lead to loss of clean design structure and high transaction speed. That's all in this chapter.